we're going to go over the equation of a line when a plane intersects a plane, which is something we've done before, but this question is written a little differently, so we're going to address this one because you may see something like this. Determine the vector equation. Okay, so a vector equation to start off, we know that means we're looking for r equals r naught plus t times our direction vector. We'll call it m. For a vector equation of a line that passes through this point A and is parallel to the line of intersection between these two planes. Okay, the first thing we want to do is we want to find the line where these two planes intersect from each other. Sorry, that's line, that's parallel. We want to find that line because that line will be parallel to a line that contains this point. So we already know that in order to do this, we're going to have to set our own parameters because we only have two equations and technically three variables. Okay? So let's go with our parameter. Same thing we did before. Z is equal to, we'll say, parameter t. So we've already solved for one of them. I won't be redundant and do that one again. Okay? With that being the case, if this is our equation 1 and our equation 2, well, I can already plug my parameter right into equation 2 and get y is equal to some parameter. So that's what I'm going to do. I'm going to take equation 2. Y is equal to 4. We replace z with t. Not equal, but plus. Plus 4t is equal to 0, which means our equation in parametric form of y is negative 4t. Now that we have a value for y and a value for z, we're going to replace z and y in the very first equation. So equation 1, we'll do it in purple here, 2x subtract negative 4t plus our value of t is equal to 0, which means we can now solve for x. 2x plus 4t plus t equals 0. 2x equals negative 5t. X equals negative 5 over 2t. So, this being the case, we now have in parametric form our x, our y, and our z. We'll rewrite them out. X is equal to negative 5 over 2t. Y is equal to negative 4t. And z was equal to t. Okay? So, let's put this into vector form so that we can relate it. We know we have our x, our y, and our z, which represent our line, vector r. What is the point here? Or what is a point on this line? Zeros. The origin. If you look here, there isn't a constant in any of these. So one of the points on this line is the origin. And our other point, or our direction vector, I should say, not our other point, is at negative 5 over 2, negative 4, and 1. Okay? So this is an equation for the line where the two planes intersect. But remember, the original question asked us for a line that is parallel to that going through this point. Well, if it's parallel, we already know that it's going to have the same direction vector, which means we really just have to replace our points. We'll call our new vector z, I guess. And what's the point? Negative 2, 3, 6. Negative 2, 3, and 6. So we replace our point, our vector, call it vector q. Okay. Has the exact same direction vector as the one above. Only difference being it goes through this specific point. So that is parallel to the line of intersection between those two planes.